Here's a neat little last example, and the point of this one is to show you that when you take calculus, the one thing that's going to happen for you to be successful is you're going to become an expert at algebra. And in this case, we're going to become really smart at factoring out the answers. So it's just a neat little example to do, and one that you can give a try on your own, because you're going to see typical examples like this in your homework. However, if we're going to integrate and we've got a product, we then identify the u as our x, and of course du is dx. And then we want to say, I need a dv. Well, we need to rewrite this radical as an exponent. So rewriting that would be x plus 4 to the 1/2. And then when we say, okay, well, how would I come up with this integral here? Well, you just think of this as a new u. If this was u to the 1/2, and our du would be 1 dx, so we've got everything we need. And when you integrate u to the 1/2, you get u to the 3/2 over 3/2. So, and you just replace that u at the end there. So our v would be, when you divide by a fraction, you get 2 over 3, you flip it and multiply, u to the 3/2. So we've got x plus 4 to the 3/2. And that's going to be our integral. So again, you got to kind of do a mental problem here with your integration. And now we have our all the components we need to fill in our formula for integrating by parts. So we have u and v, and we're going to put those together. You have 2/3 times x times this factor here. So we'll write that. 2/3 times x times the factor of x plus 4 to the 3/2. Minus the integral of the v. Well, the constant of 2/3 can come out, so we'll put it right over here. And we have x plus 4 to the 3/2 and du, which was dx. Okay, now when we integrate here, again, if we just say it's u to the 3/2, then when we integrate that, we would have u to the 5/2. You add a 1 to this power, so you'd have 3/2 plus 1 is 5/2 over 5/2. When you divide by a fraction, you end up flipping it and multiplying. So we're going to do that here. We'll bring down our term, 2/3 x times x plus 4 to the 3/2. And then we have a minus. Well, remember, our u is going to end up being here. So what that really is remember, you flip, if you're dividing by a fraction, you flip it and multiply. So 2/3 times 2/5 would be 4 over 15. And then whatever our u is to the 5/2, well, here's our u. So we have x plus 4 to the 5/2 plus c. And we're almost done here, except that we just need to simplify this answer a little bit. You notice that we could take out a bunch, and one of the first things we could take out is that the numerator has at least a 2 in it, and the denominator here has, if we take out a 15, we'd end up getting a whole number here and getting rid of some of these fractions. So we can do that. And why don't we just go ahead and take out a 2/15. And now we can say, okay, what else do we have in common? And here's the algebra part. You want to look for the lowest power of a factor and take that out. And the lowest of 3/2 and 5/2 is 3/2. So we're going to take out the lowest power of the factor of x plus 4, which would be x plus 4 to the 3/2. When you do that, you've now taken this whole factor out, and you're left here. Well, if we took out a 2/15, we'd end up with just a 5 here. And you remember that if I have 2/3 and I'm dividing or taking out a factor of 2/15, I'm dividing by 2/15, which means I flip and multiply. And here you'd get 2 over 2, and 3 goes into 15 5 times, and that's where that comes from. So we got rid of a fraction in our first term here, and we still had the x term, which we brought down. Now, if we took out, if we had 4/15 and we took out a 2/15, which means we flip and multiply, well, we get a cancel here, and 2 goes into 4 2 times. And you also have a factor of x plus 4 to the 5/2. Well, we're taking out a factor of x plus 4 to the 3/2. When you have the same base, remembering your rule of exponents, and you have different exponents, it's the top power minus the bottom power. Well, 5 halves minus 3 halves is 2 halves, or 1. So this thing just becomes times x plus 4, because it's a power of 1, and here's your plus c. Well, now let's get rid of this mess we created down here, and then we can just rewrite our final answer. So here we have equals 2 over 15 x plus 4 to the 3 halves, and then we have a factor here of 5x, and we had minus 2 times x is minus 2x, and a minus 2 times 4 is a minus 8. 5x's minus 2x's is 3x's, and a minus 8. And now you have completely simplified and factored your answer. Okay, so this problem, you may think, wow, that's just so much work. But when you get good at this, which you will by doing these problems, you're going to become an expert in algebra. Your factoring is just going to be something you get really good at. So it's just a neat example to follow. That last example we did was quite a mouthful when it came down to the factoring at the end. And I wanted you to see that there's also a different method that you can use to attack those kind of problems. And that is, what if we allowed our u to be the square root of x plus 4? Now, if I solve this for x, because I have an x term here and I want to replace it, if I solve this to undo the square root, I square both sides, and then I just subtract 4 from both sides, and I get u squared minus 4 is equal to x. Well, if I then took the derivative, because I have a dx that I need to replace, if I took the derivative, I would get that dx is equal to 2u du. I now have a lot to replace here. I know that my x, which we said was u squared minus 4, and then I have my radical, which I said originally was u, so then I'd be multiplying by a factor of u. My u was the square root of x plus 4. My x we found was equal to u squared minus 4, and my dx is equal to 2u du. Now if I just rewrite this, 2u times u is 2u squared, and then I have a u squared minus 4 factor here. So what I'm really integrating is distributing. 2u squared times u squared is 2u to the 4th, and then a minus 4 times 2u squared gives me minus 8u squared, and my du. And then integrating, I can see that I have u to the 4th, integrating u to the 4th, I get u to the 5th over 5, and here's that 2. So let me get rid of that integral. I meant to get rid of that. We're doing the integration right now. So I have my 2, and then I have u to the 5th over 5 minus, well, integrating, I have my 8, integrating u squared, I get u cubed over 3, and my plus c here. Now remember that we said u was equal to x plus 4. Well, before we go and replace anything, we can take out the lowest power of u. And we can also get rid of these denominators here. The greatest common denominator is 15. That's the least common multiple of 5 and 3 is 15. So we take out a 15. And we know that the biggest power that both numerators have is 2. We also see that they each have at least a u cubed in them. This is much easier to factor. And when you take out a 15 out of this denominator, you'd need a 3 on top, so we end up with 3 here. And when we took out a u cubed out of this term, we end up with u squared. And here we had a minus. We took out a 15 on the bottom. Well, we'd have to get, in order to make that a 15, we'd have to multiply the top by 5. And we took out a 2 here out of this 8, which would leave a 4, so 4 times 5 being 20. And plus c like this. And now we can, let's drag our paper down here a little bit, and now we just replace the fact that u was equal to the square root of x plus 4 and replace them all. So we had 2 over 15, and remember that the square root of x plus 4 is x plus 4 to the 1/2. Well, we're now cubing that, So we're saying cubed, and when you have a power to a power you multiply and you get 3/2. So we end up here with x plus 4 to the 3/2. Inside we end up with the u squared. Well, when you have a square root and you square it, you're left with just what's inside. So we have 3, and the u squared is replaced with x plus 4, and then minus 20 plus c. From here you distribute, so we had 3x plus 12 minus, 20, and we just continue to take down our factored terms. Collecting this, you see you have 3x, and 12 minus 20 is minus 8, and you get the exact same answer as we got. So there's no way to avoid the fact that regardless of which technique you use, you're going to do some algebra and some factoring. But if you replace and use a u substitution here, it may simplify your factoring a little bit because that you don't get confused with binomials until you replace them at the very end.